All right, chapter 10.2. Here we're continuing our two sample extension of confidence intervals that we talked about back in chapter 8. We talked about one sample confidence intervals in chapter 8, talking about two sample confidence intervals here in chapter 10. We're going to talk about two sample hypotheses tests coming up, I think, in the next PowerPoint, which is some chapter 11 problems. So right now we're focusing on a confidence interval for the difference between two proportions. So this is kind of the two sample equivalent of a confidence interval for proportions. How do we do this in our calculator? We do this in our calculator by hitting stats because it's stats class, tests because this would be useful on a test, and then we pick 2 prop z int. Turns out our test statistic still kind of follows that z distribution. We're making a confidence interval, so that's why we have the int in there. And we have two proportions, right? One for each sample. So 2 prop z int. So here's problem 7 from the textbook. I think I only assigned 2 problems from this section, although you're certainly, of course, welcome to do more. In fact, you can do any odd one, and I think at least most of the odd ones, the answers are in the back of the textbook. So certainly you're welcome to do some additional practice on your own, but I only assigned these 2. The 7th one is this kind of very generic problem. It has no real context, just kind of gives us the numbers to plug into our calculator. So I don't know, maybe imagine we have 2 groups. Maybe the 2 groups are 2 different types of medicine maybe. And so we give the medicine to the people, and every person either gets better or doesn't get better. And we want to know whether the first medicine's maybe better than the second medicine, different than the second medicine. So here I am filling in all the information. Not a whole lot to fill in for the proportions. So, right, x1 is like the number of people that got cured on the first medicine. N1 is the total number of people that were given the medicine. X2 is the number of people that got cured on the second medicine. N2 is the total number of people given the second medicine. And I think we're asked to do a 95% confidence interval. So that's why I picked 95. So plug all those numbers in, select the calculate option. Right, and there we go. There's our confidence interval. Also gives us the p hats. So p hat 1 is like 52.5%. P hat 2 is 30%. So right, we might say, okay, well, 52% of our sample in the first group on the first type of medicine got better, but only 30% of the people in our sample that were given the second medicine got better. Right, so we would say that we're 95% confident that the true difference in proportions is somewhere between 6.556% and 38.444%. Just like before, this entire interval is positive, right? It does not contain the value 0. That implies that the first proportion is larger than the second. So basically we're saying that we think that the first medicine is better, it's more effective. How much more effective? Somewhere between 6 and 38%. All right, here's the second problem, number 13. It's a word problem. Still kind of mechanically it's going to be the same. So if you haven't already, again, I would encourage you pause this and try the problem on your own. Then kind of go through, listen to my answers. Hopefully we got the same thing. So some traffic engineers want to compare rates of traffic accidents at intersections. This one's a little bit kind of crazy technical. With raised medians with rates at intersections with two-way left turn lanes. So we're comparing raised medians to two-way left turn lanes. I have to admit, I do an awful lot of driving. I do way too much driving. I don't really know what they're talking about, but that's all right. I think we can still fake it. So they found that that there was 4,644 accidents at intersections that had raised medians, and of those, 2,280 were rear end accidents. So that's what we're looking at. We're looking at total number of accidents, and an accident either is or is not a rear end. Looks like a little typo there. I'm not sure. I wonder if that was like an autocorrect. Um, shouldn't be rear end, should be rear end accidents. At the two-way left lanes, there was a total of 4,584 accidents, so about the same number of accidents. But it looks like a little bit less of them, just 1,982 were rear end accidents. So we want to sort of compare the percentage of rear end accidents at these two types of intersections. Yeah, so here's our questions that the book gives us. It says construct a 95% confidence interval for the difference in proportion. So we'll do that just a slide or two. And does our confidence interval support the claim that the proportion of rear end is the same at both types of intersections? So those are the questions we have to answer. So again, just filling in the information just like before, taking the numbers from the word problem, putting them in there. I was told 95% confidence. And then there's my confidence interval. Looks like, what is that? Not quite, almost just a little less than 4% to a little less than 8%. 3.8% to 7.9%. And again, we could look at the p-hat. So it looks like 49% of the accidents at that median were rear end, and 43% of the accidents at the left turn lane were rear end accidents. So again, we just take those numbers. We're 95% confident that the true difference in proportions, looks like I got it right this time, of rear end accidents between the two types of intersections is somewhere between 3.8% and 7.9%. Again, since this entire interval is positive, it implies that there was a higher proportion of rear end accidents at the raised median intersection. How much more? We think between 3.8 and 7.9% more. So you get more rear end accidents, a higher percentage of rear end accidents at these types of median intersections. Whatever that means. I guess if you're at a median intersection, dear student, please be careful. I, of course, will do the same.